like I said, isosceles triangles. Isosceles triangles is basically this. You have an isosceles triangle has a pair of congruent sides, and they also have what are called congruent base angles. The angle that is between the pair of congruent sides is called the vertex angle. That's very, very important for how isosceles triangles are labeled. Okay? That's about as goofy as any of this stuff is going to get, is knowing how to label an isosceles triangle. So if I say that we have triangle ABC is isosceles with B as the vertex angle, that just means as you label it, the B is the angle between the two sides that are congruent. Right, it's the one between. Notice also, it's the middle letter. That vertex angle is always the middle letter of isosceles triangles. Always, 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 always. Okay. It's just how they label them through. So anytime you see it, you see XYZ is isosceles, that means Y is the middle angle. All right. Does that make sense? I don't think it was really all that crazy. So if you have that vertex angle with B as that vertex angle, the other thing I want you to notice is that you have isosceles triangles that have both the sides that are the same, but these sides are pointed at what are called base angles. Those are called base angles. Now, don't freak out. Base angles aren't always on the bottom. They can be on the sides. Triangles can be spun anywhere they want. It's not that big of a deal. It's just more often than not, when you draw this, that's what you see. Okay. But, like I said, the only thing in here that you probably didn't know was that vertex angle, I'm assuming, right? The rest was pretty straightforward. So, let me explain to you how you would put this if you were ever just given isosceles. So, if you had a given isosceles, can I go ahead and clean one here? Oh, always. Grab your progression real quick. We'll put this one in here real fast, and then we'll probably start with the equilateral. Actually, you know what? Yeah. Is there any room on there or no?
There's
one.
I've got plenty.
If there's one, yeah. If you have one, I mean, you can probably split it with isosceles and equilateral. They're very, very simple. Okay. Basically, what I want to get at here is the following. It's all you're going to have is if you're given. If you're given an isosceles triangle, basically what I'm saying here is, if you're ever given you have an isosceles triangle, you're just going to state the two sides that are congruent and state the two angles that are congruent. It's that straightforward. Okay? So you'd state the congruent sides, you'd state the congruent angles. So if you knew that triangle XYZ was isosceles, Y is that middle letter, therefore it's what we call that vertex angle. So that just means that the two sides would be XY and ZY. And then the two angles that are not the vertex angle would have to be X. Yes, and the other one would have been E and C, but here it's X and Y. So you could say that X is congruent angle Did I say y? I meant x and z. Excuse me. And your reason's just definition isosceles. It's not something you see a ton of, but every once in a while they will throw it at you because as soon as you have isosceles triangle, there's so many quick little things you can do. But I think for the most part, the stuff you're going to see today and tomorrow is going to be a lot more beyond. Excuse me. Sorry. Real quick, how many degrees in a triangle?
180.
Great. I forgot to ask, did you enjoy your Culvers?
Do you see our Culvers?
I didn't get there. That's so
She got to see the moose. He exists.
Oh man, is it cute? Oh, I don't know.
Same thing, same about her. No, she's here. So, let's see. Let's go through these. Equilateral triangle. Equilateral triangle, you guys already knew this as well from back in the first section. When you have an equilateral triangle, it just means that all your sides are safe. Yes, ma'am? I'll show you. You're probably never going to be given an equilateral triangle. Isosceles is more common. This is just a definition. You know this, I hope. Equilateral triangle just basically states the fact that you have all sides that are congruent and all of your angles are congruent. And if all of your angles are congruent in an equilateral triangle, that means that all of your angles will always measure 60 degrees. Okay. Like I said, this isn't anything new. I know that once you guys first learned about triangles back in middle school and whatnot, equilateral was one of the first ones you talked about. You probably learned that all the sides are the same, all the angles have to be the same, things like that. So, shouldn't be a big deal. Basically, if you want to think about it in terms of if you were ever given an equilateral triangle, you can do the exact same thing as isosceles, but instead of having two sides congruent, you're going to have three. It really doesn't get you much. I honestly don't think I've ever seen a proof where you're given an equilateral triangle. Isosceles, I've seen it. Should we do some algebra?
We could just have here, we can.
Oh, no. I got
I guessed it right. I was like, definitely.
Your kid, you said,
That's
oh,
what
we
it
got
means.
six.
Percentage of the search
My
rate
kids.
conditioning and says
There's nine.
percentage equal. Okay. That one.
Oh no, I have an equilateral triangle.
Really?
I do. I can tell because I have 3 tick marks. And all of the angles are 60.
12.
One of my sides is 15, therefore,
12.
How
what
sure
are my other
you
sides?
That's
with an
a
equilateral?
Excellent. 74 and 36 is correct. So what's the missing side? What is it? But what is it for real?
You were like, yeah.
I know. She didn't have that look on her face. She just said it was 74. Okay. Just make sure you're okay there. Anywho, so yeah. I'll show you some algebra.
Oh. I wasn't laughing at that, just said.
So, a lot of times we'll start getting into some more of these larger style pictures.
No.
Does algebra ever go away? Oh, I think I can do this.
Oh, that's a right triangle.
It's a trapezoid. Yeah, and there's a right triangle.
I know, I
I saw
had a
some
staff
reason.
meeting this morning. I honestly forgot that I had a staff meeting this morning. I thought I was going to do that this morning.
No, that's
I-
not.
that
It's
was
a
I
trapezoid.
realized it.
Trapezoids are like.
Okay, I guess I have 2.
So let's walk through how we figure this out.
Let's start with the right triangle. It's
Yeah, me too.
right.
Because it's an equilateral.
Why is the one on the right an equalateral triangle?
These are all the angles.
All the angles are the same. So a lot of times, if you're given all the angles are the same, that means that all of the sides have to be the same, right? So that's one of the little rules. So if you just walk through the picture then, if all of these angles are the same, that means that all of these sides have to be the same. Notice I gave them just one tick mark because this had one tick mark. So what do all the one tick mark sides have to equal?
60 or no, 12. I knew that.
Okay.
I thought he was talking about angles.
You're right, the angles would be 60. I was just looking at the side length there at 12. Okay. So now, I know the one side of the right triangle is 12, and I know the hypotenuse of the right triangle is 15. How do I find the missing side length here?
Algebra.
No.
Pythagorean theorem.
Pythagorean theorem, very good. What is the Pythagorean theorem again?
A squared plus b squared equals c squared.
Remember, when you're working with Pythagorean theorem, your c value is always on the hypotenuse. It's the longest length. It's opposite the right angle. So you have a squared, b squared equals c squared. So a squared plus b squared is c squared. You just fill in the blanks. A squared plus 12 squared is 15 squared. Hey, look, math again. It's not approved. Okay. So last time I checked, 12 squared is 144,
Yeah. And that's 225.
and that's 225.
Yeah.
Subtract it out, and we get 81.
Now we got
We should probably be able to figure out the square root of 81 in our heads.
nine. Yeah.
I'm pretty sure you're right. It's 9.
It's 9 in my head. I was just thinking what to like call it. So I had the image in my head. Do you know?
So what would that whole bottom side length equal?
9.
21.
21.
21.
What do you say after everyone else?
Oh, the whole. I thought you just said.
The Y, you know?
What's up? I'm not. I haven't gone to the end yet.
Fun,
I
fun.
am. Can I scroll back up a little bit?
No.
Oh, sorry. Here, so you can see it better. What did I do here to get A by itself? I just square rooted it.
Don't you mean square root? I don't think root is.
That's what we got.
Not how you say it. But
It is.
Like if you're like, you're going
Bless
up,
you.
you say.
Guys,
square root.
come on.
You say square root.
The other part of this, when we have to go back to the angles, knowing that you have the equilateral triangle. What? Were you not done? I'm sorry. I'm sorry. Why was 21? Because we had that one bottom part. One part of the triangle was 12, and we just solved the other one would be 9.
Okay.
We're good? All right. Now, the last bit here is to try to figure out your angles. Now, knowing that in triangle SVT, I know it's isosceles because of the 2 tick marks here. Excuse me. When you have isosceles, this V is that vertex angle. It's the angle between the 2 sides, which means these 2 angles will be the ones that would be the same. Okay? Now, what does this mean?
Right angle.
And what did this mean with all 3 of them?
60.
So how much is left to get me in here? 30 degrees, very good.
Ooh.
Because you have to go 180 to form a line. Are we okay with that?
Mm-hmm.
So that gives me 30. Now, how many degrees are in a triangle?
180.
180. Knowing that I have one angle at 30, I start with the 180, subtract out the 30, and I have 150. Those 2 angles are going to be the same.
75.
Correct. So you just cut that in half, and that's how you get both of your base angles. So x is 75.
This seems pretty simple.
Hopefully it should be. Okay. Once again,
It looks intimidating. Yeah, it looks intimidating, but it's really.
once again, guys, I really can't talk over you today. Once again, is it a big deal if you forget the degree symbol? do it. It's 9 times out of 10 I'll do it too. So. Okay. All right. Question on that?
Isosceles, that's all.
All right. You need to solve for x.
Oh, no.
First of all, we need to figure out is what kind of a triangle it is.
Isosceles.
Isosceles. So if that's isosceles, notice the angles kind of point at the sides that are the same.
Ooh.
I don't know, you tell me.
Probably.
I'm just entertaining you for 48 minutes of your lives, 5 days a week.
It's working.
Thank you.
It's working.
What do you mean the other side?
Well, I wonder if you could bring it up.
The other side would have to equal 15, correct. What we're getting at here is when you have an isosceles triangle, there is a shortcut that you can remember. The algebra here is 2 steps, it's pretty quick. We got 4x equals 12, therefore x is 3. One of the things I want to show you is how we talk about isosceles in terms of an if-then statement. Okay. And it goes with the diagrams rather nicely. For example, excuse me, I'm sorry. Appreciate it. I was worried if I don't get the approval of you.
Of course you were.
Can I go to a clean one? All right.
No, wait.
If she thinks she's funny.
I know it's funny. You think she's funny too?
Looking. Ooh.
I don't have my 7 notebook, so.
Hold your nose and get a bloody nose.
Or is it time to-
Or did she actually have one?
No, one turn.
Oh.
One of the things I'm saying here is, I'll be right there, Ms. Hall, is that you can write isosceles triangles, and this works out a lot when you have the algebra. If you're given the base angles that are congruent, that means the sides opposite them. Or if you're given the sides opposite them, then the base angles are congruent. It just, how the isosceles works in terms of an if-then statement. Okay? It's very helpful to be able to use that diagram like that when you're working with the algebra problems I'm going to have you guys work on today. Makes it really easy. This whole you were asking. What? You don't need to. This is just an algebra stuff. It's not a proof thing. It's mainly for an algebra thing.
This is fun. I have down on here. Just sign it.
Yeah, you would. And the thing is, I don't think you'll ever teach us. It's I honestly don't think I've ever seen one. At least in our
See
book.
where I had this sitting. You're sitting right there.
No, you can see where it was sitting.
Also goes along with this is if I have, wow,
Ow.
if I have that, what can I say about the sides?
Oh, you don't want to get me on there.
What can I say about the sides? All the same. That's the same basic idea. And then the opposite of that is Try not to.
Probably just because the green congruent. Simple.
Very straightforward as far as how the setups of these things go. Let's try another. Let's do another algebra problem.
Wait, don't change it. Mr. Hold on. Can we do it to where like you put it out and we try and solve it?
No, I don't like doing that.
Because like by the time you get done solving,
I'm joking.
I'm gonna say you do that all the time.
by the time you get done solving it, then I actually have a picture that looks like
I'm just messing with you.
I can Google it.
Google isosceles.
Yeah.
Take a minute or two. Solve those through. Yeah. Okay. Take a minute or two and solve those through out, please.
Pretty good, too. Same. Is X.
Oh yeah, they would can.
So you have, on the first one here, you got your isosceles marks, which means these are the same. How many degrees are in a triangle?
180.
180. So you start with the 180, subtract out the 40, you're left with 140. Cut it in half, and you get 70. Which means this has to equal 70. Add that over. You get x is 8. Sir?
How do we know what to cut it in half?
Because you have two of them.
Makes sense.
there's some odd
Since you have two of them that are exactly the same, you take out one angle and they both have, you just cut it in half then. Same deal here. What do you know about these two angles?
They have to be the same.
They have to be the same, so what do you do?
Instead of me.
Stop making each other. 13 and 13, which means these are the same. So you have 7x and 5 is x plus 47. Subtract 5, subtract x, you get 6x is 42.
I have something.
You get 7 corrects. Okay.
I did that one, but
This one's 7.
That's what I was missing, was this split it in half. I had it right besides that. You're a special child.
It's more work, but it works. It works. Perfect. There's nothing wrong with that at all. Okay. Try a couple more.
Sure.
I don't know.
That was a very much creepy laugh.
You really want to play. That's more work on your hands than you're already going to do with for yourself.
Take a look at this one here. We have x's and y's here. I
I'm
am.
gonna solve the X and Y's first.
This all. What? First thing we got to figure out, what kind of triangle do we have? Isosceles. So I have the base angles that are going to be the same. Okay. I don't know what any of the angle measurements are. Not a big deal as of right now. So what would I do to solve for y?
I think instead of me.
70, right? Yeah, 70 equals to each other. So we have 6y minus 5 has to equal 10y minus 41. Now, we're going to get the y's on the same side, so we're going to pick on the little guy. Which one are you going to move, a 6 or a 10?
Damn it. At least clean it. Oh, why did you draw a picture?
Too slow.
I drew a picture.
And now what do I do? Add the 41. So you get 9 for y. Now, does that help us in finding x though?
Yes.
How?
Substitute 9 and you get to know what both of the pairs are.
Exactly. Once you solve for one of them, you're going to have to go back and substitute in and get the angle. So if you substitute 9 back into here, you get 6 times 9 minus 5. Or 10 times 9 minus 41. Well, hopefully you get the same answer for both of them. You should. Otherwise you've done screwed up. So 6 times 9 is 54. 54 minus 5 is?
49.
This one should be 49. Just double check, make sure you're okay here. 90 minus 41 is also 49. How many degrees are in a triangle?
180.
So if I take 180 next, subtract out 49 twice, I'm left with
82.
what?
I just calculated in the same.
Sorry. So I find out what that missing angle is. That missing vertex angle winds up being, has to be 82 degrees because that's all that's left. So you set that equal to your x values. Subtract the 22.
Where did I get 20
Then I heard you say it, Cam. You divide it out, you get what?
Do we get another one where there are 2 variables? I like those.
Can you give us
How about?
just so we know?
Actually, I prefer algebra proof, so I'm not
Yeah.
This is short.
Just trying to-
and quicker. And no proofs. Hey, we're going to equal that. Perimeter.
I asked you to find the perimeter of that. What would you have to do?
You gotta, first of all, you gotta find out what the side lengths are.
Right.
And
We're not finding volume. Perimeter. Perimeter, you just add up your sides. Okay. You would have to add up all of your sides. Now, when I look at the diagram, what kind of triangle is it?
equilateral.
Equilateral. So that means that all the sides are the same. Which means you have 3 different ways to solve for x. Does it matter which 2 sides you set equal to each other? Nope. It makes absolutely no difference which sides you pick to set equal to each other. Okay?
That is weird. Well, each side is 20. So.
I just chose those 2. Why? Why not?
Right.
Seriously, it doesn't make a difference. So if I substitute in, yes sir. Oh, I thought you had questions.
Could you like add all those together and then put it equal to 180?
Those are sides, not angles. Good question. Don't do that.
It's not.
What he asked was, can I add them all up to set equal to 180? No, that only works for your angles. That's just your side stuff, okay? How'd you do it so fast? I haven't even started.
You're right.
Yeah, I
You're right. Do you even know the You're right.
They're
They're
all
side
20.
length? Yeah, they're all
That's
20. You're right.
X is 7. Is that my side length though?
No. You
No,
gotta
so-
put it in.
It's 20.
My side length is going to be
20.
20.
How would I do? How?
How? 7 plus 13 is 20. 3 times 7 minus 1 is
20.
6 times 7 is 42. Subtract 22 is
20.
Therefore, your perimeter is
20.
60.
Oh, that.
It's feet squared. Not feet squared.
No.
It's just feet.
No, that's area.
It's just feet.
That's
Just
area.
feet. Yep. perimeter, you have to add up all your sides.
Gosh,
okay?
I'm dumb today.
Don't worry,
No,
I
you're
already
not.
said that too. I'm like, that's
You just
everything.
made a dumb mistake.
Mistakes. Mistakes.
To be honest with you, isosceles equilateral should be pretty easy for you guys. It really should.
And then right triangles, we just go into Pythagorean theorem.
I don't know what that is. It's a thing that
If you had Miss Lahuda, you definitely know.
I had Miss Laruda. We threw a bunch of paper towels and shot Nerf guns.
Yeah, I heard about that. You guys are assholes.
Oh my gosh, dude. She hated our class.
Sorry.
My class always was fun.
So, starting on this is 4.7,
went out into the hallway.
page 267.
Wait, when did you have?
Like,
7 to 7
I had her at 8th hour. I had her at 8th
I
hour.
had Mateo.
You were 7th hour, I'm guessing.
I had
She hated the class before us.
She hated my class. We shot Nerf guns through face
Okay.
and anything.
They're really straightforward. They really are. Okay? We're on those tonight. We'll go through some of them, see how we do.
You should tell us.
There's no proof on that.
This is how.
I know a lot of you guys are sitting there complaining about your books and whatnot. Someone next to you probably might have the book out. You can take a picture of it, and therefore you have it with you. Call me crazy. It works. It does. They got it over here.
What?
Why are you being a dick? Stop it.
Yes! Oh, you got the hand. Wait,
Where did
How
you
do you know
go
she
for?
didn't like us? She hated us.
This you tell us every day. It was